Hi George, hi Joyce. We are going over questions on the test review, and so far we have 31, 32, 35, 41. We might not do all of these three, but we're doing one to give the idea, and then we'll let you loose on the other two. And then we'll go ahead and go see number 41. And I wanted to tape so that you guys had the option of watching. Or kiddos in class, you can watch your fingers. Okay, so let's go steal this guy real quick. I'll do this so I can see the direction. Do you have paper? Oh, you don't have your spiral?
No, I thought I
Is
had
it
it.
42 or 41? 41.
I thought I had it, and then I was going to my locker to get something else. And it was right there, and I didn't even think to get it. So I thought I had it.
Okay, so long story short, they were asking about the removable discontinuity, Delio. When we were talking about algebra, it was like factor and cancel, no big deal. But the long story short of it is, can you write this function as a piecewise function with not only the original function, but also filling a hole? And how do you know if you can fill a hole? If there's a hole to begin with. And how do you know if there's a hole to begin with? If the limit exists. If the limit exists, then there is a hole that both sides of the graph are approaching. What is my discontinuity, guys, in this one? Well, they tell us, but either way, we can see it, right? So the limit as x approaches 0 of, forgive the annoying, but I just don't feel like drawing this with my mouse. So let's go ahead and steal him. Yay! There he is. Okay, now something more. Okay, I've taken the limit of him. We're also going to steal him for part of our piecewise function. However, we're only going to steal him for x not equal to 0. And we can make the function continuous if we can fill this piecewise function with an expression or a constant, bless you, that fills the hole left by the function. So, the limit of 1 minus cosine squared of x over 3x squared is 0 over 0, true? Okay, so the question is, can we find the limit? And then the second question is it a constant? 1 minus cosine squared is, oh, we can do this easier. Yeah, go team. We can just make it sine. I'm not even going to use L'Hopital's, forget that, that sounds too hard. Can't I make 1 minus cosine squared sine squared? And can't we make sine squared sine over sine? And can't we change x squared to be x over x? And can't we do all of this times 1/3? And then we're taking the limit as x approaches 0. Isn't that a special trig limit?
Yep.
And if you need to, can't you kind of do L'Hopital's and say, wait a minute, who was he? Oh, that's right. Derivative of sine is cosine over 1. Cosine of 0 is 1. Sweet. So you could do baby L'Hopital's for the trig rules. But otherwise, you have to do a chain rule, blah, blah, blah. Wasn't feeling it. So now we have 1/3 times 1 times 1. Sweet. What's the limit? Dun, 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 dun. Does it have a removable discontinuity? Yes. Why? Because we can fill it. Okay, let's say that better. Does it have a removable discontinuity? The limit is a constant, so yes. Does that make sense? The limit is not infinite. The limit is not DNE because they do not agree. The limit is a constant, so yes, there is a removable discontinuity. There's just a little baby hole. Interesting. So removable discontinuities are defined by limits. Another algebra 2 topic that you only partially could understand.
That was only part A.
And then B says define f at 0, which we did. That's our piecewise function.
So A is the 1/3 part.
Yeah, A is the limit. We can say yes, it has a removable discontinuity. Does that make sense? And then B is the defined part. So we keep the function for everything but where we fill the hole. And we fill the hole by just setting the function equal to the limit. Does that make sense, guys? It's not the greatest directions, but it is sort of AP in the thinking in the sense of trying to make a function continuous. So follow the same logic for 32 and 35. Take the limit. If the limit is a constant, A will be yes. B will be, hey, fill fill the function value at 0 with the limit itself. Okay, number 41, evaluate the improper integral state that it diverges. Yes, we will definitely have to use integration by parts. It's the only way to integrate ln. So we'll take the limit as, oh, I apologize. We need b, right? B or a. To be honest, it's the lower bound, so properly we should use a. Maybe integral from a to 1 of,
0 from the right.
thank you. Going back to it. Okay. You guys got the whole from the right, from the left thing from the notes on Friday, okay. So, as we go to solve, why do we need integration by parts? Well, there's no formula for ln. Why else do we need integration by parts? Because even though ln cannot be integrated, ln can be derived. So hence, we ought to remember, we always take a logarithmic piece if there's no way to use u sub, which there's not. We make the logarithmic piece the u, because then as soon as we take the derivative, we have the ln gone. But hold on, wait a minute. ln is all that's there. Who else is there? dx. So dx is dv, and where did dx come from? Integral of 1? Yeah. Got it. So we can go ahead and do lucky 7. And we end up with, and this is just to solve the integral, right? We have x, ln of x, minus the integral of 1 dx. Because x over x is just 1. And that's from, let me just do this. Is that okay? A to 1. Let's see if I added to it. Might not have been that much shorter. Equals integral of 1 is just
Should we pull out the x?
we could pull out the x, that's a little bit easier. If we pull out the x and then plug in a, let me steal this guy again. Oops. We have 1 times so I'm pulling out the x and plugging in 1, so 1 times ln of 1 minus 1, right? That's f of a minus a times ln of a minus 1. Is that right?
Minus that.
Oh, yeah, because I counted them out. Okay, good. So they end up with ln of 1 is 0. 0 minus 1 is negative 1. Negative 1 times 1 is negative 1. And then I have minus. Oh, we just have this guy. Jackie's already thinking about the limit, which is good. Because that's what I'm ultimately doing, is taking the limit as a approaches, wrong one, as a approaches 0. On the positive side. That'd just be ln of 0 from the positive. Ooh, hold on, wait, this is a struggle. What do we have? Isn't that going to be 0 times negative infinity? Is that indeterminate?
Yeah.
That's what we have to do.
Figure it out.
Yeah. So we're going to have negative 1 minus, because we can take the limit of that guy easy, right? Minus, can we make this one ln of a over 1 over a? We distribute, and then, remember I'm just trying to put it in L'Hopital form too. And then distribute again, and I have plus a. We can go ahead and just cancel this last piece out and be like, whatever, you're 0, right? This piece, ln of a over 1 over a, now we officially have infinity over infinity. So now we can take the derivative of the top and the derivative of the bottom. We'll end up with negative 1 minus, because that's just a constant. Derivative of the top is 1 over a. Derivative of the bottom is negative, which makes this guy positive, 1 over a squared. If we can multiply top and bottom by a squared. So we have negative 1 plus a. Whew. The limit as a approaches 0. Took us a while to get there, but what does that leave us? Negative 1 plus 0 is negative. Dun, 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 dun. Has anybody checked it? No! Guys, where's the book?
I got it.
Thanks, Shredder. Number 41 on chapter 9 review.
Is negative 1.
Woo! I thought you were about to say negative infinity. I was like, oh, Steve.
Yes, I thought you said 49, and I was like, am I reading
You're like, no, it's not right.
that?
Okay. Everybody's, can we get the questions of the main ideas?
Can we do 57?
Sometimes it costs about 12, right?
Yep.
So sorry to freak out for this. Infinite region of the first quadrant bounded by, revolved about, right, volume, express, oh, just the volume, place bar. Surface area would be a trig integral, you guys would be. Okay. It'd be trig substitution, which would never be on my AP and so on. Alright, so then we're coming down. -1 has a vertical shift down 1, yeah? So we have technically horizontal asymptote of day at -1. Oops. Right? And it says the infinite region in the first quadrant bounded by about the y-axis? Hold on.
Okay, you have to
It's not that bad. It's easier than you think.
Oh, about the y-axis. No, I was thinking about the x-axis, and I was like, oh, this is going to be disgusting. Never mind, it's about the y-axis. Okay, got it. But I saw it cross right here, and I'm like, oh, I'll stink. Okay. Bounded by first quadrant only, so we're just looking at this portion. Disk or washer? Disk, right? So you get everything in terms of y, because I think a disk is easiest. Let's not do shell, that just sounds messy. So we have volume equals pi r squared. Our y's are going to be from, 0 to infinity. Hence why it's in this section or in this chapter, because it's an improper integral. I have pi times r squared. R is going to be right minus left, which, no big deal. The right is the function curve. I just need it in terms of y. Can we do that math real fast in terms of y? Y plus 1 times x divided by 1 over y plus 1?
Yes.
Thanks. That makes sense, man.
Can you just put bottom quantity squared? Because that's what's going to be here.
Oh, I was going to do it this way. Is that okay?
Alright.
Except not. There we go. Okay. To integrate, struggle.
Just a use of.
We don't want use of. Because if we do u, it would be 1 over y plus 1. du would be.
No, you just distribute the square and you make use ey plus 1 and you.
or you just make
But then
it,
you have 1 over u squared.
or it's just pi plus
Oh, we
1
could do
to
that.
-2.
So we could end up being u to the -2 du to the bounds in a second, right? Because u is y plus 1, so then u squared is, or sorry, du is just 1. So we end up with u to the negative 1 negative, so negative 1 over y plus 1 pi. But we're going from 0 to infinity.
Is it okay if we leave the bounds like that on the AP?
Technically, you probably should have changed it earlier. I'm just being lazy and didn't want to write a lot, and I apologize. But at this case, I mean, to be honest, Gerardo, we're still following the system in the sense of now we're doing the limit as b goes to infinity. So I think you would be probably alright, but I would rather you make it proper notation. Let me get go. So we have pi times negative 1 over b plus 1 minus negative 1 over 0 plus 1. How's it looking? Because the limit as b goes to infinity, so we change that to a b and then we put the limit. There we go. Plug in our b, got it. Plug in our 0, got it. As I go to infinity, that's a 0, minus negative 1, so plus 1, and 1 times pi is, what? Pi is the infinite area that we see and it's revolved about? That's interesting. Alright. Good, well done. So that's A, B, C. It's all there. Is that okay?
E and G.
Got it, improper integral. Limit as a definite integral. Oh, okay, I didn't technically do that. You guys understand, right? You would just write the limit as b approaches infinity of 0 to b. That would have been b. Okay, I cheated and skipped. Alright, cool kids. Are you good with having a work period the rest of the time? Okay, my goal is to make tomorrow not super long. It's only 4 sections and 9-3. Remember, it's just the idea of growing faster or slower because I think it still helps with locales ultimately. And horizontal asymptotes and all that sort of stuff. So otherwise, there's your review. You guys take it away, and Joyce and George, we'll see you tomorrow for the test. Have your notes and homework spirals ready to go, and we'll bust it out.